You're set on fire. What burns first? Your skin, your nerves, or your sanity? This is how you break.
Fire doesn't just kill, it transforms you, cell by cell, layer by layer, until what's left can't even be called flesh. The human body isn't designed to burn. Every cell, every system, every evolutionary adaptation works to maintain a precise internal temperature of 98.6 degrees Fahrenheit. When flames make contact with your body, this delicate balance is catastrophically disrupted within seconds. The initial contact with fire triggers an immediate sensory overload. Your skin contains approximately 1,000 pain receptors per square inch. All of them activate simultaneously when temperatures exceed 111 degrees Fahrenheit. This creates what neurologists call total pain, a sensation so overwhelming that your brain cannot process it as discrete signals. Within 3 to 5 seconds of direct flame contact, your epidermis, the outermost layer of skin, begins to blister and split. Temperatures at the skin surface can reach 1,800 degrees Fahrenheit during active burning. For context, this exceeds the melting point of aluminum. As your clothing ignites, it doesn't protect you. It becomes part of the fuel. Synthetic fabrics like polyester melt into your skin, creating a horrific fusion of textile and tissue that emergency medical personnel call a melted composite burn. These require surgical debridement, as the material cannot be separated from your flesh by conventional means. By the 10-second mark, your dermis, the second layer of skin containing blood vessels, nerve endings, and sweat glands, begins to coagulate. The proteins in your skin denature in a process identical to cooking meat. Your skin literally becomes translucent as the collagen breaks down. The body's immediate response is to divert blood to the burn area, attempting to cool the tissue. This is a fatal miscalculation by your autonomic nervous system. The increased blood flow to damaged vessels causes massive fluid loss through the compromised skin barrier. You begin losing plasma at a rate of up to 4 liters per hour for extensive burns. Your lungs, designed to exchange oxygen and carbon dioxide, now become your greatest vulnerability. A single breath of superheated air can cause your airway to swell shut within minutes. The delicate alveoli in your lungs blister and rupture when exposed to temperatures above 150 degrees Fahrenheit. This is why smoke inhalation often kills before the burns themselves. The brain, overwhelmed by catastrophic system failures, initiates emergency protocols. Your hypothalamus triggers an extreme stress response, flooding your system with cortisol and adrenaline. Your heart rate can exceed 180 beats per minute as your body desperately tries to compensate for fluid loss and tissue damage. By the 30-second mark of continuous burning, third-degree burns develop. These extend through all skin layers into subcutaneous fat, which becomes its own fuel source. Human fat burns at approximately 250 degrees Fahrenheit, creating a self-perpetuating thermal injury that continues even if the external flame is extinguished. Nerve damage progresses in a cruel paradox. Third-degree burns destroy nerve endings, creating painless areas surrounded by second-degree burns that remain excruciatingly painful. Burn victims often report this contrast as more psychologically distressing than uniform pain. Islands of numbness surrounded by seas of agony. Your body now enters hypovolemic shock. Blood pressure plummets as up to 60% of your total fluid volume shifts from blood vessels into the interstitial space or evaporates directly from damaged tissue. Your kidneys, detecting the drop in blood pressure, release renin to constrict blood vessels, further compromising blood flow to already damaged tissue. The immune system, your primary defense against infection, becomes compromised within hours. White blood cells cannot function in severely burned tissue due to destroyed blood vessels and protein denaturation. This creates a perfect environment for bacterial colonization, particularly Pseudomonas aeruginosa, which thrives in burn wounds. If more than 30% of your body surface area sustains burns, your liver begins to fail, unable to process the toxic byproducts of massive tissue destruction. Your blood chemistry becomes increasingly acidic. This metabolic acidosis further impairs cardiac function in a devastating feedback loop. Severe burns create a hypermetabolic state unlike any other trauma. Your basal metabolic rate can increase by 100 to 150%, requiring up to 4,000 calories daily just to maintain basic functions. This metabolic demand continues for weeks after the initial injury, gradually consuming muscle mass as your body cannibalizes itself for energy. The psychological impact is equally profound. The brain, unable to process the overwhelming sensory input, often creates dissociative states. Burn survivors frequently report out-of-body experiences during the acute phase of their injuries, a neurological defense mechanism against unprocessable trauma. For those who survive the initial event, recovery is measured not in days but in years. The skin, our largest organ, never fully regenerates after severe burns. Instead, it forms scar tissue lacking sweat glands, hair follicles, and normal elasticity. This altered tissue cannot regulate temperature or sensation normally, creating lifelong vulnerability to environmental conditions. Burn rehabilitation represents one of medicine's most challenging fields. Physical therapy must begin while wounds are still healing to prevent permanent contractures. The average hospital stay for severe burns exceeds 60 days, with some patients requiring dozens of surgical procedures over multiple years. Perhaps most disturbing is how the experience of burning rewires the brain itself. The neural pathways that process pain become permanently sensitized. Many burn survivors develop chronic neuropathic pain that persists decades after their injuries have physically healed. Phantom sensations of burning that never truly extinguish. The human body's response to fire reveals both our fragility and our remarkable resilience. The same systems that failed so catastrophically during acute burning can, with proper medical intervention, gradually rebuild and adapt. But they never forget. The experience of burning becomes encoded in both body and mind, a permanent alteration to the very architecture of human existence. Next time you feel the comfortable warmth of a flame from a safe distance, remember the razor-thin margin between beneficial heat and catastrophic burning, and the complex cascade of biological failures that begins with a single moment of ignition. If this glimpse into our physical vulnerability left you thinking, don't forget to subscribe for more truths we're not meant to face.
Please remember to like, comment, share, and subscribe to help me make more videos.